Good afternoon, everyone, and welcome to our webinar. We're just gonna wait a few seconds that everyone joins. Good afternoon. People are still entering the webinar. Okay, we're gonna start. Good afternoon and welcome to our webinar, Sustainable Seas, Safer Skies, which focuses on the French MIGRALION research program. My name is Manon Thiel and I work for the Renewables Grid Initiative. For those who don't know us, I'll give you a quick introduction in a few seconds. This webinar is organized by RGI in the context of the Offshore Coalition for Energy and Nature, OCEaN, but specifically in our coalition in the Mediterranean Basin, Med OCEaN. Again, I'll give you a short introduction of those two coalitions in a few seconds. The topic of today's webinar, as I said, is the MIGRALION program, which focuses in the Gulf of Lion in France, which is a critical hotspot for seabirds and migratory birds, but also an area where our understanding of how those species navigate in the marine environment remains is still limited. At the same time, in the Mediterranean Basin, plans for offshore wind are progressing. So it is very important to bridge this knowledge gap to better assess the potential impacts of offshore wind infrastructure on this flying species. So today we'll focus on the results of this study, and we will also welcome perspective from a French NGO and a wind developer, which is also working in France. So I'm gonna give you a short introduction of the housekeeping rules. I am now hearing that someone that is not muted, so it's very timely. I'll ask you please to mute yourself if you're not speaking. It would be great if you can also change your name in Zoom and put your name and your organization so we know who we are talking to. And I am still hearing someone that is not muted, so please mute yourself. If you have questions, please write them in the chat and we will address them during the Q&A session. And lastly, this webinar is recorded and the recording will be available on our website along with the PowerPoints of our speakers. So briefly, who is RGI? So RGI, the Renewables Grid Initiative, we are an NGO based in Berlin and a unique collaboration of environmental and climate NGOs and transmission system operators from across Europe. And together we joined forces to promote fair, transparent, sustainable grid deployment to enable the growth of renewables and to achieve full decarbonization. So what does that mean exactly? We bring those partners, the one that you see, those actors, the one that you see on the slides, together at the same table to agree on positions and projects to work on, to push forward the energy transition in a way that works for nature, the climate, and people. And in line with this, in 2020, recognizing the growing role of offshore wind and its connected grid infrastructure playing in the European energy transition, RGI founded the Offshore Coalition for Energy and Nature, OCEaN. And the goal of this project, this initiative, is to promote the acceleration of offshore wind and grids alongside marine ecosystem conservation. Since we started, we have now two coalitions, one in the North and Baltic Seas and one in the Mediterranean and adjacent Atlantic waters. And we have three types of stakeholders in this coalition. We have grid operators or transmission system operators, wind industry representatives, and civil society organizations. And those two coalitions work together on filling knowledge gap, advocating for our shared messages, and create an open forums for discussions on diverse topics such as nature inclusive design, mitigation measures, MSP, and so on. Very quickly, those are the members of our coalitions in the North and Baltic Seas with the three types of stakeholders that I mentioned. And RGI is at the center as the convener, the creator of, and the moderator of the group. So this is the coalition North and Baltic Seas, and we have the coalition in the Mediterranean basin with the three type of stakeholders that I mentioned. And this time we focus on 4 different countries: Spain, France, Italy, and Portugal. If you want to know more about OCEaN, Med OCEaN, and our activities, you will find a link in the chat in a few seconds. And today we are joined by different experts. First of all, we have Sébastien Roch, who is a postdoctoral researcher at the CNRS, who will present MIGRALION and the results of the study. Manon Bourri, who is a coordinator Ocean Seas Coastal Network at France Nature Environnement, a French NGO. Alice Lopez, an environmental manager at Ocean Winds, which is a wind developer for floating offshore wind in the Mediterranean basin. And I'll be the moderator of today's webinar. So without further ado, I'm going to stop sharing my screen and pass the floor to Sébastien for the presentation of the MIGRALION study.
Hello everyone, I'm just sharing my screen. So yeah, Manon, everything's okay?
Yes, I can see your screen. Thank you.
Nice. So let's go. Thanks for the introduction, and thanks for organizing this small webinar. I'm going to talk about, of course, the MIGRALION project, which is a large-scale research program to acquire knowledge on the spatial and particular distribution of migratory birds and seabirds in the Gulf of Lion. So this work involved many different partners, and I'm working for the CNRS in France, the research institute, but I will talk a little bit later about all the different partners involved in this project. So to give you a little bit of context about this project, so Manon already told you a little bit about the context in the Gulf of Lion, but as you might know, France is at the central place of different migratory corridors with birds flying between Africa and Northern Europe and Eastern Europe. And the Gulf of Lion, which is located in the western part of the Mediterranean Sea in France, is really important for migratory birds as well as seabirds, because it hosts some endemic Mediterranean seabird species. So also floating offshore wind farms are set to be developed over the coming years in this area with different level of development. And as all of you know, birds are impacted by this offshore wind energy through different features such as collision, habitat modification, etc. But we have many knowledge gaps about how the Gulf of Lion, the offshore environments are used by seabirds and migratory birds. So in this context, the MIGRALION research program started in 2022 in 6 different work packages. So 2 between project management and gather existing knowledge, 3 work packages in charge of collecting data in the fields, and the last one, the work package 6, in charge of developing statistical methods to jointly analyze the data. So I will mainly focus on this work package 6 because I was part of this work package, and also because we were also in charge to produce some kind of synthetical maps of all the different results. So what were the main questions for this research program, and especially in our work package? So the first one is how seabirds are spatially distributed through the Gulf of Lion. The second one is almost the same question, but for migratory birds movements. So these two are spatial questions. And the third one was about the vertical distribution of migratory birds' flight heights. We didn't ignore the seabirds' flight height, but this analysis was done by another work package in the research program. And finally, all these different knowledge can inform the spatial planning of wind farms. So one of the important features of this research program is that we have many different types of data. So we have telemetry data with GPS tags and also GLS tags, different kind of geolocators. We have at-sea visual counts and observation of seabirds. We have coastal ornithological radars. These ones were deployed at different places on the coast of the Gulf of Lion. And finally, we have also at-sea radar echoes. So the main ship, which was during the visual counts, was also equipped with a radar. So just some few words about one thing really important in this research program is integrated modeling. So integrated modeling is not only something when you average different results of different data or different maps. The goal is really to jointly model all these different data types to estimate species, flight height distribution, or habitat selection. And it allows to use all the information contained in each data type, so also all the sampling bias and the uncertainty of each data types. In this context, all the sampling features of each data types are really important to avoid wrong predictions and spatial predictions. So all these things were not really available in the scientific literature. An important part of this project and of the work package 6 was to develop statistical methods to combine these different data types. So I'm going to start with the seabirds and the spatial questions. So what are the data available for this analysis? So we have at-sea visual counts of more than 20 species, the most regular species in the area during breeding season and wintering. And this comes from 4 research programs. So the MIGRALION research program, but we also gather scientific data from other research programs, which are done in the Mediterranean Sea. And we also have 4 species of seabirds equipped with GPS tags, so local breeders, so shearwaters and mainly gulls and terns. So how can we estimate species and spatial distribution from this data? So the goal is to explore the relationship between some spatial variables like sea surface temperature, distance to shore, all these kind of spatial variables, and the observation data from visual counts or telemetry. And just a small example of how it works on count data only. So we have the count data from the different research programs. So this one is, for example, for the kittiwake in winter. And then we estimate the different link to environments. So for example, here, sea surface temperature, distance to shore, etc. And then with this link to environment, we can predict spatial distribution, species of the kittiwake in winter. So this analysis was repeated for each species during breeding season and non-breeding wintering season. So it results of a lot of information and dozens of different maps. And so the problem when we have really a lot of maps like this is it's really a lot of information. It's really important knowledge for ecological things, behavior and distribution. But if you want to use these maps for decision making, for example, for wind energy spatial planning, we need to have less maps and try to synthesize the information. So here we synthesize the maps based on the species vulnerability. So maybe some of you already know this this vulnerability index. This is something already widely used in the literature, the scientific literature. So it takes into account collision risk, displacement risk, and the local conservation score. So this is vulnerability to wind energy, offshore wind farms. So we use this computation, and for each period, so breeding season and wintering season, we sum all of the different predicted distribution of the different species, and then use the species specific vulnerability index to have only one map per season. So one vulnerability map for breeding season and one for wintering season, only for seabirds. So what are the results? So during the breeding season, the high vulnerability areas are close to the coast. So this is something really consistent with the biology of seabirds, which are central place foragers. So they need to come back to the colony to feed the young. As you can see, we also compute the uncertainty or the variability of the estimation. And you can see that there's more uncertainty really far offshore because there's little or no sampling there. If we are now moving to the wintering season, you can see that the spatial pattern is really different. And we have an important area in the western part of the Gulf of Lion. And this area really overlap with the projected offshore wind farms. So the two small ones in green are already deployed. It is two small offshore wind farm with 3 wind turbines each. So what we need to keep in mind for the seabirds, that the combination of different programs enable the estimation of the distribution of the most regular seabird species in the Gulf of Lion. And wind energy vulnerability is really contrasting depending on the season, really coastal during the breeding season, and in winter, a major area in the west of the Gulf within the planned offshore wind farm. And why this important area is because we have many wintering species there, such as little gulls, kittiwakes, puffins, and razorbills. So let's move on the migratory birds now, and how migratory birds movement are spatially distributed over the Gulf of Lion. So as already told you, so the Gulf of Lion is at the core of a migratory corridor from birds moving between Africa, Spain, and Northern Europe. And there's a lack of knowledge about migratory birds movement offshore, not only in the Gulf of Lion, but this is something, lack of knowledge worldwide about the offshore movements. Usually, some birds tend to minimize overwater movements, and some other engage long offshore migratory flights. But in our case, the goal is to estimate kind of a spatially explicit migration intensity in this offshore area, and not only for 1 or 2 species, but for the whole community of migratory birds to be as representative as possible. So for the data for this analysis, we have telemetry data. So some data is coming from the MIGRALION research program, and other data from external research program. So we have hundreds of individuals between 20 and 30 different species, and we can see there's already many different locations inside our area of interest, the Gulf of Lion, for the true breeding periods. So also we have access, and this one is really important to well represented the whole community of migratory birds. We have also at sea radar data. So the radar, one radar was deployed on the vessel, and this vessel did many surveys during breeding and post-breeding and pre-breeding season. And these maps represent the number of echos of migratory birds. So I didn't put the exact number because this is a log transform number of echos, but you can already see some contrasting pattern in the data, as well on the telemetry maps. And then the goal was still to do integrated modeling, and so to jointly model these two types of data, which are really different. to estimate the migratory birds offshore spacesuits during both migration periods. And as for the seabirds, it requires substantial statistical and modeling developments. But something really different is that we can't do any vulnerability analysis because of the taxonomic resolution of the radars, and also because scores of vulnerability scores do not exist for all the different species of migratory birds. So let's move on to the results. For the post-breeding period, we have a wide coastal band toward between the north and the western part of the Gulf of Lion, with the highest intensity in the north of the Gulf of Lion. So keep in mind that this, because of the integrated modeling, these maps show relative space use. So 0 does not mean no migration, but less migration than the most important area. But they can still host thousands of migratory birds. So this is for the post-breeding season. And then for the pre-breeding season, the spatial pattern is even more contrasted, with the highest intensity in the western parts, really close to the coast. And this time with the major overlap with the future offshore wind farms. So the two small one, and also the one of the future projects, the Narbonne project here, and less intensity in the eastern part of the Gulf of Lion, less than during the post-breeding season. So what to keep in mind is for the migratory birds, this is kind of the first map of offshore bird migration through integrated modeling. And there's much more migration intensity in the western part of the Gulf of Lion. It is a bit consistent with the ecological drivers of migration, and it will overlap with future offshore wind farm projects. But keep in mind that these maps do not measure collision risk on just migratory movements intensity. So let's move on to the final analysis, which is the vertical distribution of migratory birds. So we have already a lot of knowledge of overland flight height, but it's going to be transposed because of different environmental conditions at sea, for wind thermals and landing possibilities. So the goal was to estimate flight height distribution, taking into account measurement error, because GPS are not always precise, for example, and estimate the distribution overlap with the height of wind turbines. So in terms of data, this time we'll still have the GPS data with altitude data for each GPS location, but we also have access to ornithological radars set on the coast. And we can use only the birds flying towards or coming from the sea because of we have the data on the flight direction. So with these two kind of data, we estimate the vertical distribution of migratory birds offshore. And for both migration periods, there's no really substantial differences. But the important thing is that most of the time is spent at below 300 meters. So at risk altitude, for example, so we estimated between 0 and 200, 20 and 200, and 0 and 300, for example. So just it was I'm a bit short on this topic, but the goal was to explain all the different features of the projects. So what to keep in mind for this analysis is that more than half of the time is spent at risk altitude, and even more between 0 and 300 meters. For example, for the future height of wind turbines, there's no evidence for substantial differences between migration periods. And we also tested for distance to the coast effect. This is not shown here, but because it's really dependent on it's really species specific. So some are flying higher offshore and other higher close to the coast. And so this is not something really useful to estimate collision risk or spatial planning, for example. So to give you a short summary of the project, this was a large-scale offshore research program with integrated modeling of different data types. This is something really important in this project, not analyze the different kind of data separately. It provides many new informations on bird distribution through the Gulf of Lions, and also new substantial statistical developments for integration modeling. More widely, these results are really useful for large-scale spatial planning of offshore wind farms. This is not really a precise analysis because not all species, for example, for migratory birds, are equipped with GPS, but all the different migratory birds movements are really consistent, mostly consistent between species. But also keep in mind that this project was not designed to measure impacts, but mainly to acquire knowledge about birds, seabirds, and migratory birds distribution, spatial and vertical distribution in the Gulf of Lion. So, what are the future directions of research in this area? So, the next step will be to evaluate impacts on seabirds and migratory birds. For example, by specifically estimate and model population dynamics with the future impacts and also additive pressure. This is something which is doable for the local breeding seabirds, but something really complicated for migratory birds because we don't know to which population all the migratory birds flying through the Gulf of Lion belong to. So population dynamics and all this are much more complicated for migratory birds in this case. We need to collect more data on really small birds, even if they are represented in the radar data, and also bats. And just a small information to say that the same project for the French Atlantic coast and the channels are currently under many analysis, and so I think you will hear from the results by the summer 2027, so next year. So all the information can be on this project can be found on this website, but unfortunately it's mainly in French. But if you want some English extended summaries, you can click on Synthèse Finale on this page. But I think the link of the Synthèse Finale as this document will be also provided in the chat. And you have all of this document in French and the second part in English, and it's almost 50 pages of summary of the research program. So thanks for your attention. Also, we want to thank all the different partners involved in this project. Thanks.
Thank you very much, Sebastian. And yeah, indeed, I expect that it was difficult to summarize everything in 20 minutes, but I think you did it perfectly.
Thanks.
And for those who want to know more, we have shared the link in the chat, so feel free to go and have a look. Now I would like to pass the floor to, now that we have heard of the results and how the study was done, it's important also in the perspective of Med OCEaN and the collaboration that we have with the different actors to hear different voices. And I would like then to pass the floor to Manon Bourri from France Nature Environnement, because they have also had a close look at this study, and I would like to hear their perspective. So Manon, the floor is yours. You can share your screen.
Thank you very much, Manon. I'm just going to cut my camera as well, because like that, just make sure that you can hear me well. And I'm going to share my screen. Okay, so hopefully you can see it well. It should
we see it
go on.
Screen.
Whoops. Sorry, my computer is a little bit slow because of the heat.
Okay, we all have the same problem today, I think.
Yeah, sorry about that. It's lagging a little bit, but I think it should be coming quite quickly. So yeah, just to, okay, so now I should be all right. Okay, so I'm just going to start by a quick presentation on France Nature Environnement, so FNE. So FNE is actually a federation of 6,329 associations all across France, as you can see it on the little map. And so we are lucky enough to have a local expertise across the French territory. And we also work on different subjects. So we work on the ocean, energy, biodiversity, water, but also forestry. So we do have a lot of subjects which kind of help on our expertise and to advocate for the environment. So concretely, what do we do for offshore wind power? So a few years ago in 2022, we launched the Eoloscope offshore. So that project, the idea was kind of to create a tool to help assess offshore wind project. And this publication resulted in a few workshops to present it to our associations. And FNE also participated between 2023 and 2024. So in France, we had a big national public debate on the ocean planification. And so we had a lot of our association who submitted some documents kind of advising on how we were thinking about the ocean planning. And so then all of those contributions were sent to the government. And so these documents were actually a great basis to advocate for within different government instances. And so clearly we kind of advocated for three things. So the first one was an energy mix with 100% of renewables by 2050. The second was an energy efficiency, and third, reducing energy consumption. So FNE also had a few kind of particular recommendations coming from those same documents. So the first one was clearly to expand our knowledge and understanding of bird life, which kind of resonate as well with MIGRALION. We also wanted to ensure the understanding of the state of the environment, existing impacts, and also kind of have like suitable areas for offshore wind farms. And so we also wanted to exclude offshore wind farms from the marine protected area, but also the N2000 site as much as possible to not affect too much the wildlife. And of course, we also wanted to avoid every sensitive fauna and flora. So all of those recommendations kind of lead to one thing. It's what you can see and highlighted, which means planning. Like that, we could avoid a maximum of any impacts. So yeah, we really wanted to plan with nature. It's kind of the idea also of Med OCEaN to plan with nature and to have the best solutions to avoid, reduce, and compensate. But of course, to go towards avoid, reduce, and compensate, we also need more knowledge. So once again, we really welcome MIGRALION, and it's a tool that we usually talk a lot about, because it kind of like suits with those three principles as well. So going back to the public debate in 2023, 2024, so yeah, it was kind of to plan every new offshore wind farms, and the end of the debate and the kind of results were launched in October 2024. And so this is when the government unveiled the different maps, so that you can see on the side actually. So everything that's in color is all the different like kind of new wind farms planned for the next years. And so as you can see, there are a lot of them. And yeah, so regarding the Mediterranean, this is where it was. So it was kind of what Sebastian presented. This is the Gulf de Lyon. And yeah, and so crisscrossing with the MIGRALION study, it actually showed that those sites are, very big hotspots for land migratory during pre and post breeding season, but also for seabirds, those areas are at a high risk, which is like very significant for us because in that way, crisscrossing what was the result in the public debate and what was the result of MIGRALION. For us, it's a real way to advocate for nature and for biodiversity. But it also highlighted a very important thing. So as you can see on this timeline, so yeah, MIGRALION was roughly between 2022 and 2025, I think. And then the national public debate was more between 2023 and 2024, and the MSP decisions were launched in 2024. But then it was 1 year before actually the end of MIGRALION program, which was kind of a pity in the way that in that way it wasn't taken into account into the MSP decisions, which clearly for us showed that there were kind of a mismatch between the timelines sometimes, which is also something that then we strongly advocated for, because since there is a mismatch, well, it's kind of harder to avoid before and all. And so it's more now in the reduce and compensate, which of course we need more knowledge, because sometimes it's harder to reduce or compensate rather than avoid. And so this is why we also need more planning. So it's now something that we really advocate for, because actually we need more information on biodiversity, so more studies like MIGRALION to protect some sensitive areas, and also to before choosing some very specific sites. So I think now it's very important to kind of put forward a MIGRALION study program, because it's very innovative for the developers as well to kind of know those very valuable informations on nature, and then to reduce or compensate better as well. So yeah, this is it. So this is why we also strongly use a MIGRALION program in every kind of decisions making, and also in every meetings that we have with decision makers as well. So yeah, thank you very much for listening.
Thanks a lot, Manon. And you just said you talked about this public debate, and I just wanted to highlight that last year at RGI and together with Med OCEaN, we did a public webinar to discuss the public debates and specifically look at the regulatory framework in France. So if the audience would like to rewatch this webinar, we will put a link in the chat in a few seconds. Thanks a lot.
Yeah, thank you, Manon.
And now we move on to Alice, who represents ocean winds. As Manon said, MIGRALION is a really useful tool, and having more data is very important also for the wind developers to know how to put in place the mitigation measures and to better understand the impact of the infrastructure. So that's why we wanted to have the perspective of a wind developer with us today. So I leave the floor to Alice for this. And you are muted.
Sorry, thank you, Manon. Good afternoon, everyone. I'm really pleased to join this webinar today. I will try my best to give you the insight from a developer in less than 10 minutes. So I'm Alize Lopez, and I'm working as an environmental project manager at Ocean Winds. And can you see my slide moving?
No, we see your screen, but it's not moving.
Okay, sorry. So I will quickly introduce my company. Ocean Wind is a joint venture in between ENGIE and EDP Renewables, and we are fully dedicated to offshore wind because we are convinced that this offshore wind energy is an essential element of the global energy transition, and especially under the actual weather. So we develop, finance, build, and as well operate a wind farm worldwide. And we are present now across 8 countries. So we are working on the challenges in every location. And for example, if for the Gulf of Lion, we have discussion more about the passerine. It can be up north, for example, more about the crane. So we have exchange in between the local team on this thematic. And if I give you a quick agenda, I try to split my presentation in between 3 parts. First of all, I would like to give some outlines of the environmental management through the development of the offshore wind farm in France. I will also give you quick elements of retext from outside the Mediterranean Sea project, and I will finish by giving some action we are implementing on EFGL and EFLO. So these 2 projects, EFGL, which is Éolienne Flottante du Golfe du Lion, it's the orange box southern on the map, which is a project pilot of 3 turbines, and it's actually injecting electricity to the grid. And the second one, EFLO, Éolienne Flottante d'Occitanie, is the blue box here, Narbonnaise Sudero. So here in France, so it's a particularity of some country, the developer is not responsible of the area where the wind farm is located. It's a quite long and complex process, as you discussed previously with the public debate, and the states will be fixing the area for the development of the wind farm. And once the call for tender is launched, the area is set and things cannot move anymore. So actually we are tender 10 in France, so there are the gray area, so the extension on Narbonnaise Sudero and Golfe de Fosse, and as well the 3 area in gray, Golfe du Lion Centre. For Golfe du Lion West in yellow and Golfe du Lion Est in pink, there are for later development. And the second reminder, it's also a French particularity, is when you are awarded with an area, so once the successful bidder is selected, it has the right to develop on this area. However, it doesn't have the environmental permit. In some countries, the area goes with a permit. In France, no, we have to work as a developer with environmental consultancy and as well expert to produce a file which is called environmental impact assessment. And this file is the centerpiece of our environmental authorization or permit. And in this file, of course, you have the study of the environmental baseline, but as well the analysis of impact, which leads to a list of environmental measures, for example, for avoidance, reduction, compensation, but as well for monitoring measure. And if we look for avifauna, for example, the general mitigation measure we can have to optimize the turbine layout, or to minimize the disturbance during the construction phase or increase air gap. For compensation measure, we have habitat restoration, and for monitoring measure, we'll have to equip our floater with radar and camera, but as well we will be conducted survey on the area, etc., etc. And all this list of measure, which is included in our EIA, will be then submitted through our application to the environmental authority. And the French environmental authority at the end, which will be prescribing us a list of final measures to be implemented in our park. And for this measure to be more adapted and optimized to the project, we need to base ourselves on the impact analysis. And regarding the avifauna, we will be more look into detail at collision risk for migratory birds, but as well for marine birds. So if we look at the model, they are based on turbine characteristic, which is only technical parameters, then bird characteristic, but also two other groups which are really important in collision risk assessment, which is bird behavior with avoidance rates and bird attendance at the area, such as density of bird in flight and flight altitude. And hopefully there are several research projects which are helping us to better evaluate this parameter in order to have a better collision model. So it's the case for MIGRALION in Gulf of Lion, but as well, MIGRALION is going on for the Atlantic, and there is also ABOCET from France Énergie Marine. And another project I will be detailing later on, which is Volzug. So for Volzug project, it's a wind farm in Germany. So there is a focus on terrestrial and migratory birds. And they equipped the turbine with radar and camera. And I don't have time to go too much into details, but the two main conclusions, which are quite positive, it's the first one, it shows an avoidance rate of more than 99% for the local migratory birds. It shows that the trajectory adjustment were done before entering the rotor swept zone. So the rotor swept zone, or the RSZ, is a pink area you can see on the image below, with an overall low collision risk for migrating birds. And the second conclusion is the absence of correlation between migration traffic rate and rotor transit rate, which was the most common hypothesis taken to reduce the bird collision during migration. So it means that migration peaks does not automatically translate into an increased risk of collision. They are still searching which are the other parameters. Some hypotheses are about the visibility linked to the meteorological condition, but there is not only this one. And the second example I would like to show is a focus on marine birds. So it's an example on a floating farm, Kincardine, of the offshore in Scotland. And on this one, an assemblages of camera were installed, and they analyzed the flag detection over 2.5 years. And these two important conclusions for this one regard collision rate, because collision rate in reality were significantly lower than predicted by model. So it means that the model are quite conservative, and it's a good news. And as well, they did a focus on the behavior of kittiwakes when they go through the rotor swept zone, which is the high risk area, and they show that they have a quite good behavior, blade avoidance behavior, sorry. So this camera assemblages you can see on this picture is the same that we have installed on EFGL. So the pilot project we have in the Gulf of Lion, it's the center, the image at the center. So you can see at the bottom of the turbine, we have an assemblages with two types of camera. They are facing the rotor, and they aim at monitoring the collision around the rotor and the blade. With these assemblages, we also use some CTV cameras on the right side of the slide. They are facing the float. They aim to analyze the perching effect of the bird on the platform, and to monitor the third parameter, which is the displacement analysis. We also have a radar on one of our floater. I put the link below because all of the data we will be gathering from the pilot will be published on éoliennesenmer.fr. So at the moment, there is no report because the pilot is quite new, but on the following months, you will have more and more data at this link. And if I come to EFLO, Éolienne Flottante d'Occitanie, so this project is under development. The construction is planned after 2030, so we still have time, but we are already working on the environmental impact assessment. Another French particularity here is when we are conducting the environmental impact analysis, the environmental baseline study is provided by the government. So actually we receive 1 year of data, and we are expecting a second year of data soon. And regarding MIGRALION data, they are not included in the set of data. So we are actually working with Biotop and Natural Power. So Biotop worked on the data for MIGRALION, and Natural Power is working with us, helping us to estimate the collision risk and all the impact on the avifauna. We work with them to assess the collision risk through modeling, but including as well the data from MIGRALION. And at this stage, it's important to keep in mind that the technical design of the project is not defined yet. In fact, it will be later on, but when we will submit our environmental impact analysis, we'll present our project with a different range of technical characteristics. And our main job actually is to assess the impact on the worst case scenario to be sure that to cover all the possible techniques we will be using, and this allows us to benefit in 5 or 10 years of the latest technology available. So it's a big work for the 2 consultants to try to first assess the worst case scenario and then to do the model for every scenario. So in a nutshell, if I will have 3 key messages, it's important for us to continue first monitoring, to equip the wind farm on turbines, on floater, but as well the coastal area, to pursue analysis in order to improve the risk modeling and optimize our mitigation measure in order to have them the most effective we can, and to capitalize on global data to cross among localization and among technology. And from Ocean Winds, we are partnering with scientists. We are involved in several research and development projects. And for birds, we are actually involved in BirdSafe and AvoSet, the one I talked to you previously in France Energy Marine. If you have a question, please do not hesitate to put them in the chat, and I will respond as soon as I can. Thanks for your attention.
Thank you very much, Alizé, for this insightful presentation. So as we saw, we had this really long studies from MIGRALION, and Manon mentioned that it was a bit of a mismatch with the policy deadline. And now we see that for the offshore wind developers, sometimes it's a little bit difficult to use this data because the French government has not put them or include them in the set of data that you have for your EIA. So it is sometimes a little bit difficult, as you all mentioned, to have an overall perspective for the kind of results. Thanks a lot. I would now open the floor for questions. We have about 8 minutes. I'm sure you all have questions. So if you want to raise your hand, turn on your camera and your microphone, and we will address them right now. So who would like to go first? We have a question from Alana in the chat. Do you want to unmute yourself and ask it, or should I? If not, then I just read it.
Hi.
Go ahead.
Thank you for, sorry, I have weird lighting in here. Thank you for the great presentation, everyone. And Alizé, thank you. Very interesting. And you mentioned that the government collects baseline data. And I was wondering if it's present, what's the baseline date? Is it present day baseline data, or are they using historical data for a more healthier, biodiverse environment by which to aspire to?
Hello, Alana. Thanks for your question. So for the environmental baseline study, there is a first step, which is a more bibliographical review. So they use historical data. But for the second part, the raw data given to us and transmit to our experts, there are data based on a survey in between 2022 for the first one and 2024 later on for us. And as well, so we are expecting the second year of data now, but as well, we will have to do other survey before the construction, which called état de référence in French, and sorry, reference states maybe in English or something similar. So for example, if the construction starts in 2030 or 2032, we'll have to redo again, like kind of a photography of the environment at this time. prior to the construction. So that, yes, there is this kind of tree temporality of data.
Perfect. Thanks a lot, Alizé and Alana, for your question. Anyone else? We have a question from my colleague Mathilde from RGI.
Yes, Manon, sorry, I couldn't raise my hand. So I can read it out. Thank you for the very interesting presentation. I was wondering whether I have a question on cumulative impacts and whether they were considered as part of the study and how they were taken into account. This would be for Sebastian, I think.
Thanks, Mathieu, for your questions. So now this research program and this project MIGRALION was only to acquire knowledge on distribution and not in any case to measure impact or cumulative impacts. So this will be next step. We need to have a really good baseline for basic knowledge to estimate impacts and then cumulative impacts. But I think from my point of view, we are still not ready to estimate impacts, all the impacts for all the migratory birds and seabirds in this area. We still need more data to do this. And we need also to design projects to estimate impacts and not use many different types of data which are not designed to estimate impact. This is really important. But yeah, thanks for the question, because it's still important to separate what is the project and the future use of the data.
Thanks. Thanks, Mathilde, for your question, and Sebastian for the answer. So we have a question from Hassan, who is working at CREPOM, which is BirdLife Morocco. Go ahead.
Thank you, Manon, for your organization of this rich webinar, and thanks also for the experts who made the excellent presentation. My question is for Sebastian. I want just to ask you about have you got any statistics about mortality of seabirds, especially that this Gulf or line is a flyway? And the other question is for Alizé, who mentioned very, very important things, is that the peak of migration does not mean that there is a high risk of collision. How can you explain this? Thank you.
So I hope you heard the question, Sebastian, because we had a little bit of noise, I think, from your microphone, Hassan. But
yeah, thanks, Hassan, for the questions. If I understand your question, you asked for mortality of seabirds induced by wind energy, I think.
Yeah.
But at the moment, the first wind turbines were deployed last year, I think, and the last one this last week. And it's actually only 9 turbines in all the Gulf of Lion. So at the moment, we don't have any data on mortality because this is really new. And all the MIGRALION project was done without any wind turbines in the area.
Okay.
And yeah, just I don't want to answer instead of Alizé, but just this is an important. This problem of peak migration is a really important question, and I think this is not my point of view. Is it's not entirely understood inside the scientific literature. There's no consensus at the moment. There's just few data, but maybe Alizé will have a different point of view on this aspect.
Okay, thank you so much for your insights.
Thanks a lot, both of you. So we are reaching the end of the webinar. It was very quick, but I hope you enjoyed it. And we will provide a recording of the webinar along with the slides of our speakers on our website in the next days. So feel free to share it with your colleagues who could not attend today. And if you want to have more information and news on our future events, there is a link in the chat to subscribe to our newsletter. In the meantime, I want to thank the speakers for being here with us today and providing very insightful presentations, and all the audience and the participants for joining us. I wish you all a very nice end of the day. Thank you.
Thank you, Manan. Thank you.
Thanks. Bye-bye.